When we have multiple forces acting on a rigid body, what we're able to do is we're able to simplify those forces. And one way we're able to simplify those forces is something called a force and couple system. Now, as the name implies, we're going to replace all of the forces we have with one force, and one couple. So one moment. Now, the steps we need to do to take this are pretty easy. Step 1, we're going to sum our forces in our x direction. Step 2, we're going to sum our forces in our y direction. Now, we're going to take the forces in the x, the forces in the y, and for step 3, we're going to figure out what our resultant is. So that's the square root of fx squared plus fy squared. Step 4 is we're going to figure out what our angle is. And our angle will be the inverse tangent of fy over fx. Then finally, what we need to do for step 5 is we need to get the resultant moment of our system. And this resultant moment is going to be the sum of all of our moments about whatever point we're looking at. And I'm going to put point P because that's what our example problem is asking us to do. Our example problem is asking us to replace this force system we have with an equivalent force and couple moment at point P. And so these are the steps we're going to follow. So let's do that. Step 1, let's sum our forces in the x direction. So this force right here, this 430 pound force, that's going to be a minus 430 times the sine of 60. The other force we have is this 260 pound force. That's going to be plus 260 times 5 over 13. So let's see what that number is. And we get this is minus 272 point, we'll call it 4. And we're in pounds. All right, so we did step 1. Step 2, we sum our forces in the y direction. All right, when we sum it in the y direction, this is also minus 430. This time it will be times the cosine of 60. And then we'll have plus 260 times 12 over 13. And let's figure out what this is. And we get this is equal to 25. Okay, so this is the sum of the forces in the x. This is the sum of the forces in the y. And now step 3, we need to figure out the magnitude of this. So my magnitude of my resultant force is going to be equal to the square root of minus 272.4 squared plus 25 squared. And right away, I can tell you it's going to be pretty close to 272 because that 25 isn't going to do much. So if we square that, plus minus 272.4 squared, take the square root, we get 273.5. And that's pounds. So we want to remember this. So this is the magnitude of the moment, and we have our force. Now, the last thing we need to do for our force is figure out this angle theta. So theta, well, which way is this going? Let's break it down. Let's look at our x direction first. Our x direction is going in the minus direction, and it's 272.4. Then our y is going upwards, and it's only 25. So this is going to be a really small angle, this angle right here. It's going to be the inverse tangent of 25 over 272.4. and this is 5.24 degrees. And we want to remember this. So this is our result. This is the force we have. Its magnitude is 273.5, and the angle it acts is 5.24 degrees up from this minus x direction. So now that we figured out our force summation in the x and y, what we want to do is step 5, which is figure out our resultant moments. If we figure out our moments about point P, we'll have this. So what do we have? First, we need to break up this 430 pound force into a x and y component. Let's do the x component first. So we have this right here. When we rotate this, and we'll rotate this counterclockwise in a positive direction, this is going to be 430 times the sine of 60. It rotates about point P head first, so it's positive. And this perpendicular distance is right here, so it's a distance of 8 plus 3, so 11. Now, what about the vertical distance? Well, if we break this up and we look at this vertical distance, well, it actually goes right through point P, so it creates no moment about point P. So we can just ignore that. But for this 260 pound force, we're not going to be able to ignore it, either of its components. So we're going to have one component that goes this way. We're going to have one component that goes like this. So this component, this vertical component, is going to rotate head first. So it's going to be plus 260 times 12 over 13. And now that's the force. What's the perpendicular distance? We have 5 plus 2, which is 7. So this is going to be plus 7, or times 7. And then we have our horizontal component. And with this component, it's going to rotate tail first. So it's going to be minus 260 times 5 over 13. And its perpendicular distance to point P is just 3 feet. So we're going to have this is times 3. And then we put this into our calculator. And we'll get what our resultant moment is. So we get a resultant moment that's positive, which means it's going counterclockwise, and its magnitude is equal to 5,476.3, and we're in pounds and feet, so in foot pounds. And this is our answer. So we've replaced these two forces with a singular force that is at point P. So the force at point P, it has a magnitude of 273.5 pounds. It acts with an angle of 5.24 degrees. And we also have a moment that is 5,476.3 foot-pounds. So that is the equivalent system at point P.